Good morning, everyone. On behalf of the organizing committee and of the Federal University of Bahia, I'm delighted to welcome all participants of the 5th International Conference on the History of Quantum Physics, HQ-5. We are thrilled to host you here in Salvador from August 11 to 14. This event is particularly significant as it marks the first time an HQ event is held outside of Europe. This conference revives the influential HQ series, which previously convened in Berlin in 2007 and 2010, in Utrecht in 2008, and Donostia San Sebastian in 2015, playing a crucial role in revitalizing the community of historians of the quantum physics. The importance of the HQ-5 is further heightened as it's one of the global events of the International Year of Quantum Science and Technology. We're especially excited about the direct connection between the HQ-5 and the 6th AIP Early Career Conference for Historians of the Physical Sciences, which took place here in Salvador from August 4 to 9, and we have many early career scholars here who have attended the previous conference. The linkage is intentional, as we aim to foster interaction between different generations of historians of physics and encourage new scholarship on the history of quantum physics and its technologies. I would like to highlight that this auditorium is named after Milton Santos. We can see his photograph at the background there. He was one of the most influential Brazilian intellectuals and a black geographer who was recipient of the Voltrin Lund Prize, which is often seen as the geography's equivalent to the Nobel Prize. So this event would not be possible without the general support of our partners and sponsors. We extend our heartfelt gratitude to the partners of the International Year of Quantum Science and Technologies, that you can see in this slide. The Brazilian National Council for Scientific and Technological Development, CNPq, the American Institute of Physics, the Inter-Union Commission on the History and Philosophy of Physics, and we also acknowledge the crucial support of the Physics Institute and the Geophysics Institute of the Federal University of Bahia. Finally, we appreciate the endorsement of the International Union of Pure and Applied Physics, IUPAP. The conference is rich and diverse, featuring 25 oral presentations across 9 sessions and 10 posters presentations. We are also privileged to host several keynote speakers, lectures that of leading scholars. Notably, we will hear from Hanoch Gutfreund, I'm sorry for my pronunciation, Margriet van der Heijden, Daniel Hu, Elise Krau, and Alexei Kozhevnikov. Additionally, the conference will feature 2 roundtables on historiographical debates. The first one is titled 2 Decades of Scholarship on the History of Quantum Mechanics, and the second one is Visions for the Scholarship on the History of Quantum Mechanics. Now, we are honored to have a distinguished panel to join us for the opening sessions. Please welcome Christoph Lehner, who is one of the founders of the HQ series and a representative of the German tradition of the history of quantum physics. Please, Christian. Roberto Lally, who is a representative of the Inter-Union Commission for the History and Philosophy of Physics and the International Union of Pure and Applied Physics. William Thomas, representing the American Institute of Physics, the director. Yes. William Thomas is the director of the Center for History and Policy of the American Institute of Physics, whose former director was Gregory Good, who had a very important role in promoting the global community of history of physics. Thank you. Olival Freire Jr., representing the National Council for Scientific and Technological Development. Cássio Bruno Magalhães Prigoso, who is director of the Institute of Physics of the Federal University of Bahia. So I would like to invite each of you to have to say an opening remarks. You have about 5 minutes for. Can begin with Christoph, please.
Being the fossil here, this came rather surprising. This question, so I might be a little bit confused. But just a few reminiscences about how this all started. I worked in the late 90s and early 2000s at the Einstein papers in Boston and then at Caltech. And of course, these were still the years where the Einstein papers were centrally focused on general relativity. And in connection with that, there were these HGR conferences, History of General Relativity conferences, that were, played a very important role back then in the study of the development of general relativity, and created this very nice community of people working on it. And if you've ever looked at these, these volumes from the conferences, they were really important scholarly work done by, a bunch of people that, formed this like tight-knit community of general relativists. And so when I moved on to Berlin in 2004, Michel Janssen, who had been my colleague at the Einstein papers, went on to Minnesota, and Jürgen Renn in Berlin. We sort of had the idea that, work on general relativity had been not done, of course, nothing is ever done, but, the most important, it was sort of, it was time to move on to something new. And the obvious candidate was quantum mechanics and quantum physics in general. And so Jürgen started at the Max Planck in Berlin this project on the history of quantum physics. And in connection with that, we, and I think it was especially Michel pushing for that there should be sort of some equivalent to the HGR conferences also for the history of quantum physics. And this is how the idea got born in, I think we had like a preparatory conference in 2006 in Berlin, and then, oh, sorry, I'm not close enough. So, and then the first conference, Climerio said it was in 2008, right? I'm a bad historian, I never remember dates. And it started rather small, right? It was there were not that many people working in the history of quantum physics back then, and it's also there was not like that much of a sense of like there is this community there, and I think it's very nice to see that over the years this really the field developed very much, and one thing that I find also really striking is that history of general relativity was still sort of very much this white male European enterprise, and when I look now, who is here now, it has become much more, gender equal. There is way more women in the field. It's much more international, right? We're like, here we are in Brazil, wonderful. And so I'm very happy how this has developed, and I'm very grateful that Climerio picked up the tab and is continuing this tradition, and I think there's still lots to do. I mean, that is the wonderful thing about quantum mechanics. It's such a huge and complex story, right? It's not just the story of Albert Einstein sitting in his attic and struggling with the field equations. There's so many people involved. There's so many social factors involved, so many historical, political factors involved. So, yeah, I'm hoping this will continue for a long time. I will have more of that. Thank you.
Hello everybody, my name is Roberto Lalli. I know that there are quite a few early career scholars who attended the first conference, so for a few of them it will be a little bit of a repetition. Can you perhaps, yeah, thanks a lot. So I'm here more as an institutional role. I am the new chairman. New chairman means since 1 month of this commission here, International Union Commission for the History and Philosophy of Physics. If you're able to pronounce the acronym, you will get a prize next time. Can you go to the second, the about page? Okay. Okay, so we The commission exists not as an interunion, but a commission in the more in the historical history of science union, scientific union, since quite a while. But in 2021, thanks to the previous chair, who was Jaume Navarro, and thanks to Alexei Kožesnikov, who proposed the idea to Jaume, and thanks also to me, who worked with Jaume, closely to Jaume, to change the status of the commission, it became an inter-union commission, also financed not only by the Division on the History of Science and Technology, but also by the International Union of Pure and Applied Physics, which created quite a few novel possibilities, a little bit more funds, not much, but a little bit more funds. But what is important is kind of new possibilities. Before this change, when Climerio was organizing the AIP conference on the early career historians of the physical sciences here in Salvador, I proposed him, why don't we connect it with a more, conference for more senior scholars, not that there might be connection between early career, more senior. And I thought that he would never accept. After 2 days, he said, well, that's a great idea. Let's do that. And so this is how we started. I was really surprised. But eventually, thanks to the support also of UPAP, this became the global event of the quantum year of science and technology devoted to the history of physics. And that is one of the amazing things that can be done thanks to this new role of the commissions in connection with the International Union of Pure and Applied Physics. Now, I would like to use this time to present a couple of things because it may be useful to continue what Christoph said. I mean, the community building activities, it requires quite a lot of work to build in diverse, international, hopefully global community, which is about quantum physics, but also more generally in the history of physics. So I would like to take this time to present what we have in mind as a commission, because we need, the input from the community itself. It's not. The commission will not do a top-down work. It is to be a bottom-up approach for this to work. So what we can do, what is possible to do, and we will try to do, is to, with the IUPAP support, to have a flagship conference in the history of physics, somewhere possibly else than Europe and the United States, the first time. And that can be done with some support to UPAP already in 2027, and we have to make the proposal by June 2026. So there is this idea which I asked you to think about, how that we can realize first a UPAP flagship conference in the history of physics. And the second thing we can do is now having prizes for the early career once per year, and we will give it every 2 years, but it's once per year, an annual prize, which might be important for the continuation of the career early career scholars, but also for presenting the work to a broader community as a spotlight. So please keep an eye on what's happening in the commission and try to cooperate with us to make it happen. Our main goals is to support early career scholars, to promote the field internationally, possibly global, and to allow it to develop more broadly than it is to now. So the program is incredibly interesting. I think that's a wonderful way to start in connection with the previous early career conference. So this is a kind of request to keep this going from the future and also in relation to the commission works. Thanks a lot, and have a wonderful conference.
So my name is William Thomas. My official title is the Spencer R. Wirt Director of Research in History, Policy, and Culture at the American Institute of Physics. What that really means for our purposes is that I direct AIP's history program. I'm the successor to Greg Good, who many of you may know, and before him, Spencer Wirt, and before him, Charlie Weiner. So it's an enormous responsibility to take on. I've been doing this for 2 years. Many of you probably don't know me. My background is in the history of science. I finished my PhD in that in 2007 at Harvard. I had a postdoc at AIP. We've had a number of people come through our postdoc programs, including Alexei up there in the corner. So that's a program that we're going to be restarting quite soon. It's been on hiatus since 2019, I believe. And AIP, we're coming up on our 100 years of existence, and for most of that existence, we have supported work on the history of the physical sciences, really since 1961. We provide research resources. Many of you may be familiar with our oral history program. We have about 2,000 oral histories in the history of the physical sciences, including many of the transcripts online from the original archive for history of quantum physics. We also have a wonderful visual archive, which has about 30,000 images, including many frequently used images from the history of quantum physics. And we have many other resources, both online and in our library in College Park, Maryland, in the United States. Aside from being a library and archive, we also aim to facilitate the development of a community of historians of the physical sciences. So one of the ways we do that is through the Early Career Conference that took place last week. That was an innovation of my predecessor, Greg Good. And we're delighted that that can be paired with HQ-5 in order to help create a community not only among young people, but among different generations in the history of quantum physics. So that's very exciting, and we hope that that continues for years to come. We also offer a granted aid program. We give out about 10 grants per year that are a maximum of $2,500 each, and those can go to scholars anywhere in the world for research anywhere in the world. It used to be to help people come to us, but as many of our own research resources have gone online, our aim really is just to help cultivate research wherever and whenever we can, and many of those have gone to the history of quantum physics. Michelle Frank has been working on some of our grants on her project on Qiansheng Wu. Just recently, we gave out a grant to Luisa Lovisetti to do work on the history of quantum physics in Milan. Yuxin Fang at the University of Minnesota has been working on, just returned actually from England to work on the history of Einstein scholarship and the politicians and the political leanings of people who are involved in that. I'm sure that I'm probably forgetting many in this spontaneous moment, but it's a wonderful program, and as I say, we had 19 applications this spring. We have 2 application cycles per year. April 15th and November 15th are the deadlines for that. We had 19 this spring. We gave out 6 grants this spring to people from 6 different countries on 4 different continents. And I think that's just an extraordinary sign of just how developed the community is. We also aim to help increase communication within this community. So up until this spring, our primary mode of communication has been our semi-annual newsletter. This was the one that just came out this summer. It has David Bohm on the cover, which is both a nod to his role in as a quantum physicist, but it really is attached to his experiences during the Red Scare of anti-communism in the United States during the 1950s, which turned him into somebody who went from country to country to try and find a home, and that's sadly a history that's become all too relevant now in the United States as we're experiencing increasing political pressure. But twice a year is really not frequent enough to create a lasting dialogue. So this spring we just launched a weekly email newsletter and a separate monthly email newsletter that aims to just make people feel a part of the history of physics community much more frequently. And if you're not signed up for that already, you can go to aip.org/newsletters, and you can sign up for both of our history newsletters as well as several other email newsletters that AIP publishes. So yeah, I think I'll leave it at that and simply say that in this year of IYQ, our aim is to really focus on the history of quantum physics, and I'm excited to have more conversations about that with all of you. Thanks very much.
Good morning to everyone. I have two comments to do in this open session. The first one concerns the building of communities, in this case, community of historians of science dedicated to quantum physics. But I would like to give a testimony in which concerns the role of this conference and the early career conference in the building of a small but active community of Brazilian historians of physics. I can say that since the first HQ, there was a Brazilian over there, a colleague of ours who is not here, Roberto Martins. In the second conference, if I'm not wrong, Fabio Freitas and Ana Paula, we have participated in this. And since then, we have participated in all these conferences. In addition, through this conference, we were able to have an agreement signed between the Max Planck Institute for History of Science and the Federal University of Bahia, which was very important for us. It was not an agreement with money, but the symbolic role played by this agreement was very important, not so much inside the university, this was important, but in our relationship with the other historians of science and history at large. In which concerns the early career conference, when this initiative was launched, I did not participate because I was no longer a young historian, 2010 or 2011. But I can tell that since the first one, an important number, a meaningful number of young Brazilian scholars have participated too far. Then these initiatives are very important, and I would like to thank very much the Max Planck Institute and the American Institute of Physics in supporting this building of community. For us in Brazil, this has been very, very important. The second comment, the CNPq, this Brazilian agency for funding research, since the beginning, we were very sensitive to the UNESCO initiative of dedicating 2025 to the International Year of Quantum Science and Technology. And we had a call, and the people here, Climério won one of these grants. And we did this because we have a strong perception that quantum mechanics is a very important part of the scientific culture in our world. Not only because it is changed the technological landscape, everything we are doing now with this microelectronic device are based on things like transistor, laser, etc., which were fruit of quantum mechanics, but also because quantum mechanics became a central pillar of the physical knowledge about the world. But not only this. Quantum mechanics also impacted I would say the cultural landscape in our world, the philosophical landscape, with huge controversies about the meaning of quantum mechanics, and last but not least, in the last decades, we are entering in a field where we are learning more about quantum mechanics with entanglement, with the coherency, more about applications, and we are on the verge, or at least we have the potential of entering a new set of technological applications. Then for all these reasons, it is very important to diffuse the knowledge about quantum mechanics, not only among physics students, physicists, scientists in general, but I would say at the society at large. Thank you very much.
Good morning, all. Allow me to read some lines here so don't forget anything, please. It's a profound privilege to welcome you all to the 5th International Conference on the History of Quantum Physics, HQ-5. This year's edition holds a special significance, being part of the United Nations International Year of Quantum Science and Technology, a global celebration of curiosity, discovery, and the enduring quest for understanding. For the first time, HQ-5 ventures beyond Europe, and we are honored to host it here in Brazil. This moment is more than symbolic. It reflects the vitality of our scientific community and the increasing recognition of Latin Americans' contributions to global scientific dialogue. I'd like to congratulate the organizing committee in the name of Climerio for facing this amazing challenge of bringing this meeting to Salvador. As acting director of the Institute of Physics at the Federal University of Bahia, I'm deeply honored to stand before such a distinguished assembly of scholars, historians, and physicists. Your presence here affirms the power of collaboration and the importance of revising the intellectual journeys that have shaped the quantum theory. Over the coming days, I hope you all not only exchange ideas, but also build lasting connections that transcend borders and disciplines. May this conference inspire new perspectives and deepen our appreciation for the rich and complex legacy of quantum science. Welcome to Bahia, welcome to Brazil, welcome to HQ-5. Thank you.
Thank you all for your opening remarks. I would like to thank the organizing committee who has been meeting for about a year from now, since October last year, if I'm not mistaken. The organizing committee is formed by Alexander Bloom, who unfortunately could not come to Brazil, Daniela Monaldi, Indianara Silva, Tinhan Leo, Roberto Lali, Tiago Hartz, and Will Thomas. I would also like to thank the local organizing committee.
Did you mention yourself?
Sorry?
Did you mention yourself? I didn't.
Yeah, myself. I'm also like to thank the local organizing committee, like Carla Almeida, who's there. Guilherme Aragão. Okay. Tainan Alcântara, who's outside. Bárbara, I forgot his name. André. Poliana, Eliud, que está... Eliud Souza, que está aqui, e seu colega? Lá que filmando. E Nicolas, está ali na filmagem. Okay, muito obrigado. Without further ado, I look forward to engaging in this fruitful conference and insightful. I hope you have insightful discussions along the week and valuable networking opportunities. And I sincerely hope you all enjoy your time in Salvador, both academically and exploring the rich and scientific cultural heritage of our city. Thank you very much and welcome. So, yeah. Hello, everyone. Now we resume the conference with our first keynote lecture by Professor Margriet van der Heijden, from the Professor of Science Communication and Physics at the Department of Applied Physics at the Eindhoven University of Technology, who is going to present the talk, Women in the History of Quantum Physics, Beyond Knabenphysik. Please, Margriet.
So thank you. Let me first ask, can you all hear me? Yes. Yeah? Because my voice is not too strong. So please wave if I forget to hold the microphone in the proper place. So first of all, thank you, Clemerio, and thank you all for this opportunity to speak here on behalf of our international working group, Women in the History of Quantum Physics, and on behalf of all its fantastic members. Women in the History of Quantum Physics is an APS-FHPP-supported group of historians, scientists, philosophers of science from at least 9 countries, from Brazil, from Canada, Germany, Italy, Mexico, the Netherlands, Portugal, Spain, the US, China, which I'm at 10 now, and I hope I didn't forget anyone. Today, I hope to give you a clear impression of what we do and what our aims are. So, when quantum mechanics was developed in 1925, some of the physicists involved, you see 3 of them here, you see Fermi, Pauli, Heisenberg, looking very happy at Lake Como in Italy in 1927. But some of the physicists involved were so young that 8 years later, at the Nobel ceremony, they brought not their spouses or their partners, but they brought their mothers instead, as Alexei Kozhevnikov noted in his book, The Copenhagen Network. And in fact, it was the youthfulness of these quantum heroes that led Hermann Weyl to describe the quantum revolution as Knabenphysik in 1946. And in doing so, Weyl illustrated how the image of physics had shifted from a discipline developed by eminent men with impressive beards often and wavy grey hair, who mostly worked in solitude, to a discipline propelled by a group of extremely smart young men who competed and collaborated simultaneously. Now, historians of science like Arne Schiermacher and again Alexei Kozhevnikov have shown how this explosion of quantum activity, one could say, was also stimulated by the advent of large physics centers with a very strong focus on theoretical and mathematical physics. And all the collaboration and competition was, of course, further enhanced by novel means of mobility and novel means of communication. Think of railways, steamboats, cars, an efficient postal system, the telephone. And all in all, I think the term Knabenphysik seems to have captured something refreshing, signifying youthfulness, daringness, novelty, collaboration, and modernity. However, what went unnoticed, by most at least, is that the term also held an implicit assumption, because Knaben are not only young, Knaben are also men. Or in other words, the term offers a gendered perspective on developments in physics and reinforces the stereotypical idea that physics is a male business. And it is one of the aims of our international working group, Women in the History of Quantum Physics, to show how limited such a perspective is and how much more justice we do science when, quoting Will Thomas from one of his AIP's newsletters just mentioned, we build a more expansive and realistic history of physics that is unbound from an exclusive focus on pantheonic achievement. Now, of course, many historians of science have already nuanced the popular account of a handful of Knaben achieving all these quantum successes. For example, as John Heilbron already put it in 1968, the development of quantum physics is intimately linked to that of other branches of physics, Think of statistical mechanics, the study of radioactivity, spectral analysis, the theory of atomic structure. And as Korzhevnikov in his aforementioned book, The Copenhagen Network, also beautifully demonstrates, is that many more players were involved in the quantum field itself as well. However, as the philosopher and historian of science Massimiliano Badino has observed 10 years ago, but still, where history of quantum physics lags shamefully behind other kinds of histories and philosophy of science as well, is in the incorporation of geographical and gender perspectives. And focusing on gender here, the narratives he wrote remain as male-dominated as the discipline as a whole. And again, it's the purpose of our group, through the volume we recently published. I brought it with me. And through forums we organize, through a web exhibit that we are currently preparing with the help of the American Institute of Physics, to repair that and to broaden the perspective. But before diving deep into that and immediately turning to quantum physics, let me briefly jump back in time to around 200 years ago, before the advent of quantum mechanics, to the beginning of the 18th century, when 3 women from wealthy families, all 3 of them, who had received wonderful private education, all 3 of them, were appointed members of the Bologna Academy of Sciences. The first was the physicist Laura Bassi, you see her on the left, and the third was the mathematician Maria Gaetana Agnesi on the right. And both came from Bologna, and both were appointed professors at the University of Bologna. And that was certainly not trivial in practical terms, as women were not allowed to enter the university buildings. So Bassi lectured from home, while Agnesi effectively never lectured. And in between them, in 1746, Émilie du Châtelet was also made a member of the Academy. And in fact, I think she's one of the few women scientists whose work and life have become famous during the last decades, not least also by the work of some of our WikiP members. And likely du Châtelet became most famous for translating, as you all probably know, Newton's Principia from Latin to French and annotating it. But the reason for mentioning her here is because in one of her many other notable works, du Châtelet also focused on the role of women in science. She did so in the introduction of her translation of the Fable of the Bees of the Dutch-British philosopher Mandeville, in which she wrote, qu'on fasse un peu réflexion pourquoi depuis tant de siècles, or in other words, let's reflect a little bit why during so many centuries never a bonne tragédie, so a beautiful tragedy, a beautiful poem, a well-esteemed history, a magnificent painting, or a solid book of physics has come out of the hands of women. And then she goes on to ask, why is it that these creatures that seem to be equipped with, nowadays we would say, a brain, just the same as man, semble pourtant restés par une force invincible, so seem to be withheld, held back by an insurmountable force. And Émilie du Châtelet, living in the period of enlightenment and being a child of her time and very empirically oriented, then also proposed a way to address this question. Were I king, she wrote, I would like to try this physical experiment. I would redress an abuse which cuts back, as it were, 1/2 of mankind. I would give women the right to participate in all human activities, especially those of the mind. Or, in other words, she proposed to create a level playing field, equity for all. However, as we all know, something different happened, because at the end of the 18th century, the French Revolution took place. It led to the Declaration of the Rights of Man and Citizen, but Despite protests from feminists such as Mary Wollstonecraft, women were not included as citizens in this declaration and not given the citizens' rights. And if we focus on academia after the revolution, when Napoleon conquered Bologna, his troops burned down the library. With it, they burned Bassy's papers, and he then forbade women to work at universities again. A backlash that some see or perhaps experience in a different shape in our times again. But to continue, the 19th century in a sense set out with a playing field in academia that was very far from level, and I think one could even say that women and academia began to grow further apart, because while women were blocked from participating, universities expanded, they modernized, they tried to keep up with the growing industry, the growing demand for skilled workers, for research and development of new products, and also for the new hunger for knowledge from a rising middle class. Yet all of this also made the question of women in academia more urgent. And what I show here on the right, well, you recognize her, is Maria Mitchell, who bridged the gap between being an amateur as a woman, because she was not allowed to receive an academic education, and academia. She did so by becoming the first American to discover a comet that was invisible with the naked eye. And it led to a lot of publicity, and also to her becoming the very first member, for example, of the American Association for the Advancement of Science, and to become the very first woman professor in astronomy at Vassar's College, one of the women's colleges that were established throughout the 19th century, and especially in the second half of the 19th century in the United States. And what I show on the left is a picture of the chemistry room of the Bestuzhev Institute in Petersburg, St. Petersburg. That was one of the institutes for higher education for women that were established in Russia in the 1870s, so also in the second half of the 19th century, and that were in a way a counterpart, one could say, to these American colleges. And then in between, in continental Europe, the normal universities, so to speak, began slowly to open their doors to women. But all of this always took place amidst fierce and heated debates about women's education, about its purpose for society, about its desirability, its risks for family life, the children, and more. And I think it's fair to say, also when reading papers about this period, that even when universities opened their doors to women, it was never a given that a woman could receive a good education, attend university, or pursue a career in academia, and let alone venture into the more curiosity-driven realms of science or the humanities. And it's probably fair to say that most people were more comfortable with women acquiring an education that would make them interesting spouses, enable them to raise their children according to healthy and academically sound principles, or participate in socially oriented enterprises. And as Max Planck, so here now I arrive finally, sorry, after my detour at the quantum era. As Max Planck wrote in a book, Die Academische Frau, with all sorts of short essays on women in higher education, Amazons are also a natural in the intellectual field. Amazons here standing for an independent women making her own life. There might be some exceptions, he added, and I included a picture of Lise Meitner, who would become such an exception in his own department. But in general, one cannot emphasize enough, he said, in allgemeine, aber kann man nicht scharf genug betonen. One cannot emphasize enough that nature itself has prescribed the woman's role as a mother and a housewife. Now, of course, not everyone thought the same way. Pierre Curie in France is an example, Hendrik Lorentz in the Netherlands, Marian Smoluchowski in Poland, for example, were all in favor of women participating in academia. And in Göttingen, at the end of the 19th century, Walter Nernst employed several female assistants and PhD students. And in the years before the quantum revolution, so I'm stepping back a bit again, Felix Klein and David Hilbert, the mathematicians, for example, also welcomed female students and PhD students. You see some of them here again, so close to David Hilbert on the right. You see Nadezhda Gernet and Lyubov Sapolskaya, who went on to become mathematicians in Russia. On the left, so near Felix Klein, we see Grace Chisholm-Young from the United Kingdom, and finally, I could not leave out, of course, the formidable Emmy Noether from Germany. Yet, despite such exceptions, women must have felt that not everyone surely welcomed them heartily, especially when they took new career steps. We see that, of course, in Noether's trajectory, because during the first years of her long career, she could lecture in Göttingen only under the guise of Hilbert's name and without receiving payment. And in other words, it was not easy, to say the least, I would say, to escape the expectation that women are less adventurous, less curious, less analytical, more subservient, more caring, and therefore less suited to academia. And it must have been tough for these very first generations of women. It can still be tough, but especially for them it must have been tough to be systematically underestimated and undervalued, a phenomenon that the brilliant Margriet Rossiter, who sadly deceased last week, would coin the Matilda effect. And with a bit more of cynicism, one could also say that for some men it was all too easy to exploit such stereotypes by offering these women who finally had a chance to enter academia a low salary and a position defined by routine tasks. And how this could work out is illustrated in the very first book written by Keegan and Bratislav Friedrich about Wilhelmina Fleming, who was one of the calculators at Harvard College Observatory at the end of the 19th century. You see a group of the calculators here, and here on the left we see Charles Pickering, the director of the observatory. Now, Fleming was not one of the women like, for example, Henrietta Leavitt, who had received a good education at one of the women's colleges in the United States. Fleming, having emigrated from Scotland to the United States and having become a single mother, had been employed in the household of the Pickering family initially, as a housekeeper or a help in a household. And there she had been recognized, especially also by Pickering's wife, as being very smart. Moreover, she had learned the details of the photographic process from a very young age, because her father was a photographer. And this made her very well suited for her work as one of the 17 women calculators at the observatory who were supposed to analyze the photographic plates that were burned during the night. And in fact, Pickering will probably not have seen her lack of astronomical knowledge as a big issue, because the women in his laboratory were chosen, as is quoted here, to work, not to think. It's a quote of a paper by astronomer Cecilia Payne-Kaposhkin. And their task was to systematically analyze all these photographic plates and not to interpret them. And for this work, they were paid a very meager 25 cents per hour. The labor in turn helped Charles Pickering build a true factory observatory, because these plates were taken during the night, they were analyzed during the day, so it was 24 hours per day going on, and it sped up the work enormously. And it certainly also helped Pickering advance his career, which was adorned with all sorts of honors and prizes. And in the meantime, Fleming played a pivotal role at Harvard Observatory as well, discovering, analyzing and classifying numerous stars from various types and making a discovery that would be crucial to quantum developments. because in 1896 she noticed that the spectrum of Zeta Puppis, a star that is hotter and more luminous than all other stars in the Milky Way, differed from the spectra found until then. And in retrospect, this was because it was a spectrum of ionized helium, which is very abundant in this star. And this series of spectral lines of ionized helium would then become known as the Pickering series and would turn out to be crucial in lending Bohr's model of the atom credibility, because it was only after Bohr showed that his model could worked to calculate the proper Rydberg constant related to this specific spectra of both hydrogen and helium, that Einstein exclaimed, as John Stachel described, the theory of Bohr must be right. Fleming herself did not live to see all this. She died from pneumonia and exhaustion in 1911, and her part in the work would soon be forgotten for a long time, her name eclipsed by that of Pickering. Now fast forward 2.5 decades and we meet Jo van Leeuwen, who in 1919 defended her thesis as a PhD student of Nobel laureate Hendrik Lorentz in Leiden. And Jo van Leeuwen, in fact, was the 4th woman PhD student of Lorentz. We see Lorentz in the photograph right on top, in the middle, with a beard, a little bit of wavy hair, and surrounded by his students. Bottom right, we see his first PhD student, which was his daughter, Bertha de Haas Lorentz. Nowadays we would say she was a Nepo baby, I think. But in those days, apparently, you could have your father as a PhD thesis advisor. Then there was Johanna Reutler, and right on the top photo, Eva Dina Bruins. And then there was Jo van Leeuwen. And in her thesis, she very convincingly and comprehensively demonstrated that the phenomenon of magnetism, be it ferromagnetism, paramagnetism, or diamagnetism, cannot be explained on classical grounds, so cannot be explained if you use Maxwell's theory and statistical mechanics. She did so by describing multiple cases, dipoles, free electrons in metals, and all other types of molecules in gases, and by comparing her calculations to previous work by Lorentz, Langevin, Thomson, Schrödinger. But what she did not know at the time was that Bohr had proven the same thing in 1911 in his dissertation, based only on free electrons in metals, so less comprehensively, and published in Danish. So this thesis had not attracted much attention and was soon also to be overshadowed by his 1913 results. Nevertheless, the later Nobel laureate John van Vleck was so impressed by van Leeuwen's work that when he wrote his seminal book in 1932 about magnetic permittivity and electric susceptibility, he spoke of the van Leeuwen theorem only, and he mentioned Bohr's work in a footnote. Now, of the 4 women, van Leeuwen was the only one to continue in academia, and I think this can be explained from the fact that in the Netherlands, social conventions, strict social conventions, really prohibited women, once they were married, from having a paid position or having a paid job. And in fact, these conventions were translated into law in 1924, so a law that truly forbade married women to work. Jo van Leeuwen never married, so she escaped that fate, but you could say, it still took her quite a while to find a position, even despite her very successful thesis work. Once she did, at what is now Delft University of Technology, it was a rather subservient position. She supervised practical work, the practicals of students in the Department of Electrical Engineering, and this job left her a little time, almost no time, to pursue her own research, let alone to establish her own line of research. And even by Dutch standards, it would take very long before she would be promoted to at the next level of reader and be allowed to lecture. She had to wait for almost 30 years for that. And by that time, Van Vleck had completely changed his stance on the work of Van Leeuwen and Lawrence. So in the 1950s, 60s, 70s, he who was previously so impressed by Van Leeuwen's work would now only mention Bohr's work and mention Van Leeuwen in a footnote. Van Vleck even went as far as to say that the work from 1911, so showing that magnetism cannot be explained on classical grounds, must have been an incentive for Bohr to develop his quantum theory. And the striking aspects here, of course, are invisibility, particularly in the case of Fleming, I would say, and isolation, particularly in the case of Van Leeuwen. And that brings me back to this emblematic expression of Knabenphysik, which, as we saw previously, refers to young men with raw innate talent who are adventurous, rebellious, who bond into a boys' network. And now, if you consider these women who were among the very first generations to set foot in a laboratory or a university building, that were often the only women present in their research group, that were very likely not convinced that they possessed a raw talent, that were also often dependent on one progressive mentor amidst a group of people who saw no room for them, and that never were automatically part of a network, a boys' network, then one realizes that their trajectory certainly was not an easy one at all. And Van Leeuwen and Fleming were surely not the only ones who must have felt exhausted and intimidated and overwhelmed from time to time. These consequences of not belonging to a boys' network have, of course, been previously discussed by many. Think of Maria Rentezzi, for example. And they are painfully evident also in the career of Jane Dewey. In contrast to Van Leeuwen and Fleming, Jane Dewey managed to obtain a postdoc position, so you could say that's progress. Yet in a wonderful chapter, Adriana Minor recounts how Dewey, after she was trained at Barnard College in New York City, went on to work with Bohr in Copenhagen using a scholarship to carry out an experiment on the Stark effect in helium. So the Stark effect is the splitting of spectral lines in the presence of an external electric field. And her experiment was successful, yet despite this success or her efforts, Bohr prioritized the publication of a parallel result from another visitor, J. Stuart Foster. And okay, Bohr being Bohr, perhaps one cannot solely ascribe this to gender prejudice. It occurred more often. Yet, Minor convincingly shows how Bohr's manner and tone nevertheless hampered her work, and how, adding to her disappointment upon returning to the United States, Dewey landed a postdoctoral position in Princeton, where very few saw place for women in physics. The atmosphere was such, in fact, that she was called Mackay's Folly, with a reference to William Mackay, who had supported her postdoctoral position. And so, unsurprisingly, after some more of such experiences, Dewey went on to work in industry, while Foster made a career for himself. And we find him back in another chapter in our book, the beautiful chapter on Laura Chalk by Daniela. And what we see is that Foster befriended Heisenberg, and that later, in his memoirs about the birth of quantum mechanics, Heisenberg always would refer solely to Foster's work and never mention the work of Dewey. Likewise, in their chapter, Michel Janssen and Gernot Münster describe how, after a very successful period as a PhD student in Hamburg and a postdoc in Göttingen, Lucy Mensing was driven to despair and out of physics also, when she became an assistant in Tübingen. In Hamburg and Göttingen, Lucy had written no fewer than 3 highly relevant papers. In the first, based on her dissertation, she studied the Stark effect. She too, that was very instrumental, of course, to the development of quantum. And she did so for diatomic molecules in a gas. And she showed that only integer values of the orbital momentum of the electrons in these diatomic molecules were allowed. And yet, the spectrum seemingly required half-integer quantum numbers. And what she then did is show that when you use the new mechanism of matrix, the matrix mechanics, so the freshly developed tools of quantum mechanics, that indeed the spectrum could be explained by using integer values for the orbital angular momentum. And in fact, that was in line with the proposal, of course, of Sam Goudsmit and George Uhlenbeck to introduce spin, which was half integer. And for those who love this topic, I should also mention Ralph Kronig and Wolfgang Pauli, of course. In her second paper that she co-authored with Pauli, she successfully described the electric susceptibility of gases based on quantum mechanics. And then in the third, she discussed the partial Paschen-Bach effect. I will not go into that, from a quantum mechanical perspective too. Yet in Tübingen, her supervisor, Alfred Landé, would hardly speak to her. If he wanted to discuss the latest developments in quantum and in physics, he traveled to Hamburg to talk to Fritz London instead. Even though Mensing and London's contemporaries, they were of about the same age, considered the work of London and Mensing to be on a par. So Mensing was very much left on her own, and Münster and Janssen even argued that in 1928, Mensing's marriage was perhaps not the final blow to her career in physics, but rather an option that allowed her to deal with her frustration over this unproductive year being lonely in Tübingen, and more importantly also to escape a highly competitive environment that we would nowadays, I think, call toxic, and where she in any case developed an aversion to the masculine role models around her. Now, Fleming, Van Leeuwen, Dewing and Mensing are just 4 of the women featured in our volume. That in total covers the lives and work of 16 women. And as Elise Kroll, I use the idea of the slide from Elise, will hopefully demonstrate during her talk, the number of women we could have written about could easily have been many times higher. And I will leave it as a surprise for Elise's talk to get to know how much higher we think it could have been. For now, I want to say that these 16 stories in our book reveal aspects of all sorts of mechanisms that seem to hold women back. So I had a question that Émilie du Châtelet asked in a way. And some of these stories, like that of Fleming, Van Leeuwen, Dewing and Mensing, reveal the aspects of invisibility, isolation, a lack of networking, as well as the struggle against this culture of fierce competition and raw masculinity. Other stories also highlight other aspects. For example, Elizabeth Monroe Boggs' story, written by Patrick Charbonneau, illustrates how the loss of women from the field of physics, which is very often described as a leaky pipeline, can be a gain for other fields. So what in physics is seen as a loss can be a true gain elsewhere. In the case of Monroe Boggs, she became a prominent public advocate for children with disabilities. And what was a gain, a big gain for that field. The lives of Carolyn Parker and Chen-Ching Wu illustrate how racial and gender biases produce an even stronger pushback against attempts to establish a career of one's own, a phenomenon encapsulated by the concept of intersectionality, of course. And overall, I would say, to me at least, it was striking in what fertile ground the Knabenphysik pictures seemed to fall just after World War II, which was a period where traditional values were being restored, where women were sent home, where one-income policies were designed, tax systems were built that favored the family as the cornerstone of society. And where in some countries, like my own, women did not even have the right to open a bank account or buy a car or other property. And where in academia, I would say women were marginalized a bit again. And in this respect, I also want to very briefly mention Lydia Salguero, I hope I pronounce it properly, and Herta Sponer. Salguero and her partner, José Francisco Gómez Ferreiro, they supported one another when they were forced to reinvent their entire research agenda in response to political pressures in Portugal in the 1940s and 50s. And what Ana Simoes and Maria Paula Diogo show in their chapter is how instrumental Salguero was to that effort, how integral she was to the group, offering crucial scientific guidance, and how yet, unlike the outgoing Gómez Ferreira, she was a totally behind-the-scenes researcher and almost invisible to the outside world. So reading the chapter, one gets the impression that the couple almost were enacting the expected roles of women being modest and of self-effacement and of male visibility and being outgoing. And then Sponer's story, which will of course be discussed in much more detail by Elise, illustrates how such gendered expectations result in the outside world attributing less value to women's achievements too. So Krull refers to Sponer as the maven of spectroscopy. And what is striking is just last week I glanced over the interviews, the oral history interviews of the American Institute of Physics and the ones that were conducted by Thomas Kuhn and Maria Gubbert with James Frank and Sponer. And if you read these interviews, then Sponer hardly get asked any questions from time to time. From time to time it seems as if it's an interview with Frank, and then Sponer is a passerby that sometimes can add some comments too. And one could perhaps attribute her invisibility, and you will hear much more about it, to the fact that she was an experimental physicist, and so entering the league of what Stephen Shapin has called the invisible technicians. But I think this also illustrates once more just how firmly this image of a bunch of brilliant, rebellious young men defining the course of physics had taken root also after World War II. Or as historian of science Naomi Oreskes put it, emphasizing attributes associated with masculinity, the heroic ideology renders the scientist invisible. The marginalization of women in science is a predictable consequence of heroic rhetoric, regardless of whether the individuals invoking such rhetoric are consciously sexist or not. And it is for this reason that in our volume we also wanted to stay away from the well-known women who did make it to the pantheon, the ones who became hyper-visible, solitary and unattainable icons, a phenomenon described by Julie Desjardins in her work, the Madame Curie complex. Instead, we wanted to highlight those women who were unable to attain this status of heroines of science, who were prevented from participating fully as equals in the professional networks, and who struggled with internalized prejudice, perhaps, and surely with gendered social norms. And we feel this is important also because the image of brilliance, competition, raw talent and boys networks continues to affect individuals and their hopes and dreams for the future, especially also through all these popular accounts that perpetuate and continue to share this story of this handful of Knaben. And what I show here is a typical example on the left of one of the results of the surveys conducted since the 1960s among many thousands of children. And these children, aged between 8 and 14 years old, were asked to draw a scientist, which is a clever way to reveal how they conceptualize a scientist, because they probably do not yet have the words to describe this conceptualization. And what you see is that, in fact, many of the this is a very representative drawing, because many of the children always draw a crazy hair figure, inspired by Einstein, I think, either working in a laboratory with chemicals and explosives and dangerous signs, or standing in front of a blackboard with lots of formulas that no one understands. And in the 1960s, and you can see that here on the right, only 1% of girls drew a woman scientist. And recently this figure increased to around 60% among girls. And if we average boys and girls, then we arrive at almost 40% of the drawings representing a woman scientist. And interestingly, and maybe not coincidentally, I don't know, this 40% is about the same number as we now have women PhDs in STEM fields. I could say something about role models perhaps or not. However, there's one discipline that lags shamefully behind, and that is physics, where we only find 20% of women in PhD positions. And in a long line of research, the psychologists Sarah Jane Leslie and André Simpian and their colleagues from New York have shown that a key mechanism through which this underrepresentation is produced is, according to them, the existence of a culture of male competition in those fields. So they point to an organizational environment of ruthless competition that discourages female participation and that also fosters imposter syndrome in women. Here I've shown a plot of a slightly different study. What they did here, it's the same group, is ask people in academia in the United States whether they thought that brilliance was required to succeed in a certain discipline. And what you see here on the horizontal axis is a number that represents the belief in the necessity of brilliance. So the further on the right, the stronger the belief is that brilliance is required. And what we find on the right is physics, math, philosophy, music, composition, engineering. And then what we see on the vertical axis is the participation of women, so the percentage of women participating in a field. So if we look at physics, we see a strong belief in brilliance and a very small participation of women. And you could say that what we see is kind of representation of the Knabenphysik emblem, if you take a shortcut. Now, to summarize, what we in our working group aim to do is to demonstrate what an oversimplification it is to reduce quantum developments to such tales of brilliance and competition as is still often done in popular scientific accounts. And as said, our goal is to contribute to a more comprehensive and a realistic history of science that includes scientists of all genders, I should say. I focused here on women, because also historically there is this binary, but we aim to include scientists of all genders. And we also aim to investigate the factors that hold back some groups, particularly women in our book, from participating. Or you could also say, in essence, we seek to address this question that Émilie du Châtelet already posed such a long time ago, and that so many after her also posed. So I have pointed to some of the aspects that lead to this unsurmountable force that seem to hold women back. So it is isolation and invisibility. It are societal preconceptions about raw talent and a culture of competition. It's also interrupted careers, like in the case of Mensing, who married and could no longer work, even though it was for her, in her case, perhaps an escape. The hidden labor in science, you could think of Sponer, but many other women conducting experiments. Intersectionality, I mentioned Parker and Chen Jingwu. Collaborative couples, think of Salguero. And if you want to read more, please read our book. And let me then, in summary, also summarize our aims once more concisely. We want to normalize the presence of female physicists in the history of quantum physics. We want to mainstream gender analysis in quantum physics historiography for all genders. And we want to help to dismantle the stubborn gender stereotypes and biases that continue to hamper gender diversity and inclusivity in quantum physics. And this continuous hampering is also visible. Let me name one more chapter from someone who is here, Mar Rivera's chapter on Anna Maria Cetto, with which we end the book. And then finally, let me thank you for your attention. Let me thank the Forum on the History and Philosophy of Physics from the APS for their support. And let me thank all the wonderful members of Wikipedia for their contributions to our volume, to our website, and hopefully in the future to much more.
Thank you very much, Professor Margriet van der Heijden. We have a time for questions and comments from the audience. Please don't be shy. Okay.
Thank you. Does it work? Okay. Yeah. I would be very interested if you comment a little bit on this tacit assumption that married women should not work, because I kind of encountered it in many different societies, but usually sort of uncodified, kind of without specific rules, or maybe, I don't know, maybe American high schools have this rule that kind of women could work as teachers in the high school until they're married. So could you do maybe some kind of a comparative kind of a view on kind of in which countries kind of the rule existed and what way of it existed as a formal law or kind of as an informal social convention, and when they abandoned it?
I hope I understood the question correctly. So you would like me to comment on a comparison between countries about the fact that married women were not allowed to work. Let me begin with the Netherlands first, which is my home country. So there the social conventions were very strongly opposed against married women working, no matter their type of education. So this had, I don't know whether I understood your question correctly, but it didn't have to do anything with qualifications of those women. It was just the fact that they were married that forbade them from working as a public servant, and then all companies followed suit. And this lasted until 1957, until this law was abolished. And I think if you look at Germany, for example, you find very similar policies as in the Netherlands. You see, for example, also after the Second World War, that the Adenauer government instated a tax policy that was very similar to the one in the Netherlands. Now, of course, this is very continental Europe centered, because the situation was very different, like in the Soviet Union, where women were allowed to work. And in the United States also, women after the Second World War surely were also not refrained, I think, by maybe there were social conventions, but there were no laws surely to prevent them from working. It was a reason also for some women to go to the United States from Europe, I would say, in the second half of the 20th century. Now I must admit that I'm not familiar with the situation in Brazil, for example, so maybe someone else can comment on that.
I just have another comment or also praise and an anecdote I think that adds to this. So I'm working on Heisenberg, and what I did is very much analyze how he presents women in his work, because he doesn't make explicit sexist or misogynist comments, but we can see how he constructs the history of physics or quantum mechanics in his works by seeing that he has a specific preference. and who is supposed to work and who has the cognitive abilities. So recently I came across again his interview that his wife did after he died. And she recounts after she met Heisenberg, how he was like a little bit frustrated that she couldn't follow. And she said, asking him, should I study physics? Because I was very good at physics. And he was, no. So I think there is also the masculine perspective on wanting maybe a specific wife that might be educated enough to raise the children or be supportive of having certain level of conversations, but maybe not have the same level to not start competing or be challenging back. So I think you tease that out very well, these different aspects playing into women becoming invisible in the history of quantum mechanics. But yeah, it's I think also a nice anecdote.
Yeah, thank you for sharing. And it taps into a broader discussion on women's education. Of course, if you look in the 19th century, there were a lot of debates on women's education and whether it should be geared towards, well, science that is helpful in maintaining a household. So learning about diets or learning about health. For example, so you see those discussions taking place in all over Europe, and I would say in the United States as well. I think Joanna Berman has given a nice talk on that, for example. Thank you.
Hello, good morning. Thank you for your wonderful talk. I wonder what are your thoughts on why these 16 quantum women, they are left out from our quantum historiography, and what actually we lost when we are not able to see them, and as you saw us during your talk. Thank you.
Thank you for the question. Yeah, so why they were left out from historiography, I think has very much to do with this image of Knabenphysik or this image of competitive culture. And I hope I showed some of the mechanisms at play. Okay, they were at play to keep women out of physics, but they were perhaps some of them also at play in the minds of those people studying the past. Like the Matilda effect, you could say, or the presumption that you need a kind of raw masculine, very competitive culture. And then the second part of your question was?
What we lost as a community by not seeing them as a historical actors and actress, and so.
Yeah, so, well, I should first say I'm not an historian of science. As I'm a particle physicist by training who got lost in science communication and the history of science. So maybe my answer is a bit general, but I got asked this question last week also by Physics World, by a podcast, and I answered it with a metaphor. So in the past, let's say when describing classical physics, especially in the more popular scientific accounts, but also in the historiography, developments in physics or science were very much described in terms of what you could see as a ladder. So one genius standing on the shoulder of the other and then creating like this human ladder. We have genius on the shoulder, and again a genius, and again. Now the Knabenphysik was not a ladder, but it was like some acrobatic show with making a pyramid or whatever, but still standing on one another's shoulder. And I think what you would really like to do is sketch an image of a mountain range, where the scientific knowledge is built like a mountain range, and where you have science educators, science communicators, people building instruments, instrument makers, people conducting experiments. You have all sorts of people, and they build this mountain, and it allows some people also to rise to the top, from where they can see further than all the others. So what we miss out is that yeah, we have a limited picture. We look at a kind of acrobatic show of instead of at this whole mountain range and this whole collaborative effort that involves so many more people. And of course, like in the book, the Copenhagen Network and so on, many people have already tried to broaden up this picture. This is not, yeah, but it is what we miss out, I think.
First of all, thanks for your presentation. And my question is, how do you see or how do you analyze the gender influence on the construction of concepts in physics? Because in history and philosophy, we're always talking about the cultural influence, the political influence, but not about gender influence. So I'd like to know, how do you see this, if gender is an important aspect on the influence, or on some aspect of influence the on the construction of conceptual framework of physics?
Oh, this I find very hard to answer. I would say whether there would be how the gender perspective could affect the concepts of quantum mechanics, is what you are asking. I must say I would not really truly have an answer to that. Maybe one of my Wikipedia members would like to say something more to that, but I would not feel capable of doing that. What we do see is that many of the women were conducting experiments, for example. So I gave Herta Sponer as an example, but you could also mention Chen-Jing Wu, who conducted beautiful experiments. And one could say if more attention would have been paid to those experiments, like Chen-Jing Wu's experiment on the entanglement, which was the very first experiment conducted on entanglement, maybe developments in physics would have gone faster, would have gone more rapidly if they had not been left out. So the team would certainly have been larger, so the effort could have sped up, a bit like in Pickering's laboratory, but then hopefully in a more equitable manner. But whether it would have affected the concepts, I find that very hard to answer. Sorry about that.
Hi. I have a question. Well, you said that there is a cultural image on. There was a cultural image on women, that women were not capable of doing scientific work, were not good enough to work or think academically maybe. But I was wondering, well, in the sense that women, at least in higher society, they were not allowed to work because of this cultural image on what women should do. But at the same time, you have women, like in low-income women, that must work. And I wanted to understand, like, how this cultural image of women impact low-income women, and if that the stories of these low-income, they are also like, they could also help to think about women also, the place of women in society, and maybe like help think on the historiography in some way, and if that was also seen in any of the stories that are inside your book. Thanks.
Yeah, thank you for the question. It's, you are right that especially when you look at the period before World War II, it were very often women from the higher classes that had a chance to go to university, like a Jane Dewey who went to Barnard College. Or if we go further back in time, Émilie du Châtelet, who was a noblewoman, and the situation of course was completely different for women who just had to work to survive or to help their families survive. For those women, of course, it was even more difficult to bridge the gap with academia, because very often they had to start working at a very young age, and no chance to to get a proper education. And this is not so long ago. In fact, my own two grandmothers, my one grandmother, she had to go working at the age of 10. And the other at the age of 14. So I think they would have liked to see me talk here, but they can't be here. But it's true that there's a big divide between the classes in this sense. And in our book, I would say we do not have so many examples of women coming from a very lower class background. But there is Fleming, of course, the very first chapter. Fleming was, without a proper education, went to the United States, became a single mother, got a job in the household of Pickering, and then still succeeded to rise to a relatively good position in the observatory. And that was also, of course, partly luck that she got to work at the Pickering household, and that Pickering's wife recognized her talents. But I would say in our book that is the best example. I hope this doesn't fully answer your question, but it surely is an interesting topic, perhaps also in future to look into a bit more.
Okay, we are running out of time. It's already in the coffee break time, but we have a comment from one of the authors in the book, and you have one question, and then we close the session. Okay?
Yes.
You.
I just wanted to say thank you to Margriet, and also to all the great questions. And I may have missed something that Margriet said as we whispered about the next steps, but to your excellent question about socioeconomic realities and the variety of socioeconomic realities. Actually, what is hard to see in the slides, but you'll see on the actual cover, is a quote from one of the women who's profiled in the chapters, talking exactly about this issue of underpayment. And
Which is Fleming. This is Fleming.
Yes. And how in her work, the employers seemed to presume that she could make do on a very small salary. Especially in the Harvard laboratory, there were a great number of women who had no other alternative, or accepted a very small salary in order to do the work that they were passionate about. So your question makes me realize that is a subject that needs to be amplified. And even in our cover, we've got it there, but it's in a muted text behind the title, which in some ways is very symbolic and sort of metaphorical to the difficult issue that you raised. So thank you for pointing it out. There was a question in the middle about what might happen if we experienced a regendering of concepts within the realm of physics, and I don't know that I can answer it any better than Margriet already did, but one writer comes to mind who might be interesting to read, and that's Karen Barad, who talks about physics from a gendered perspective and what happens if we bring some potentially still conventionally gendered ideas about women and connection to the structure of our thinking theoretically and conceptually, and how that thinking transforms and changes. So there is some interesting work on this. It's not part of our book, but it's out there. And I think that's the next chapter in some of this research and conversation. I'll pass the microphone up in front of me for the last question.
Okay, thank you. Very, very quickly, I was wondering which period exactly did you cover, and have you planned to go further on with the history of quantum physics in the 30s, 40s, 60s, and so on? I mean, in the rest?
Thank you for the question. We covered a period roughly, starting with William Minna Fleming, who has now, whose name has come up several times. So that is late 19th century. And the last chapter, so we go in a chronological order. The last chapter is about Anna Maria Cetto, who was one of the people behind the International Year of Quantum Science and Technology, of course. So, we were bound a little bit not only by, in Dutch we have a saying that between your dream and what really happens, there are all sorts of practical obstacles always. And one of the obstacles, of course, was to find people who were able to write chapters also. So our 16 women are just a selection, and we cover, roughly speaking, the period from the late 19th to the late 20th century in 16 chapters or 16 windows that give a view on quantum developments in a very broad sense of the word. So we had a very broad perspective on quantum developments. And the practical objections are partly related to gender, in the sense that sometimes it's very difficult to find a paper trace. If you think about Carolyn Parker, for example, which was one of the first black woman to pursue a career in physics, then I think Charnel Long, I don't know where you are, Charnel. Oh, he did a tremendous, a wonderful job to find, to retrace this paper trace, and that can sometimes be very difficult. So it's truly a selection that we present, and if one would like to, one could write, to answer your last question, way much more. But so please be welcome if you have the time to write another chapter or paper, perhaps.
Okay, let's thank Professor Margriet very much for this wonderful talk. So before we go to the coffee break, I would like to correct an injustice that I committed here and thank the graduate students who are doing an amazing job here. Fernanda Braga, who is there, please. Bruna Alencar. Milena Amoedo. And Tiago Faustino. Yes, they're working mostly in the background, but this event wouldn't be happening without their help. So thank you very much.
So welcome to the second keynote lecture, the first day. I have a couple of announcements, I think. The first one is that if you are freezing, it's not possible to lower or increase the temperature. So either we turn it off and we will, suffer another kind of issue, or we have to stay with this temperature. I will not make a survey now, otherwise we lose time, but I mean, you can choose basically if we want to freeze or to die for the heat. And the second thing, we have to be very strict because unfortunately, I mean, so the lunch is not here. So the bus leaves, the bus has to come back. If you think about that, if we don't start in time, it means that we will basically have to rush the entire day, try to find the bus, etc. So we will stop on time, and we will start now. And it's my pleasure to introduce the second speaker, is the second keynote speaker, with Hanoch Gutfreund, who spent his research time as a theoretical physicist and becoming also the president of the Hebrew University of Jerusalem, and has been the director of the Einstein Center, taking care of the archives at the University of Jerusalem. And since a few years, thanks also to this role, he has been working as an historian together with Jürgen Rehn at the Max Planck Institute for the History of Science, publishing a number of successful books by Princeton University Press on relativity theory, the road to relativity, the formative years of relativity, the Einstein revolution, etc. And now they have done a new project, which they did under figure David Bohm, which is very important here in Brazil, and is very much connected to different interpretation of quantum mechanics, based on published 1957 lectures of him. And this book will be out soon, and this will be the topic of Hanoch Gutfreund presentation. So, helping me welcome Hanoch Gutfreund for his.
This is forward? Yes. Okay. A few years ago, a colleague of mine at the Hebrew University, a physicist, died. His widow allowed me to browse in his library. And there, to my surprise, turns out to everybody's surprise, to all the Bohm scholars' surprise, I found a manuscript, typewritten, on this manual multiplier that were used in those days, of 114 pages by David Bohm, delivered in 1957 to a group of Marxist physicists. Now, the attendees at those lectures were partly students from the Technion, from the Hebrew University, but mostly members from the kibbutz movement, the kibbutz settlements that were established by a youth movement, Hashomer Hatzair, the Young Guard, which was an ideological, socialist, verging on communism movement in Israel in those days. Now, these lectures were never mentioned again by Bohm. They were not known by anybody. They were not known at the archives, the Bohm archives, and yet they constitute a unique document of the kind that Bohm has never written before and never written after. In this book, with Jürgen, we present those lectures with our commentaries and also putting that in a broader historical, philosophical, scientific context. Now, let me just... So before I introduce you to those lectures or to those lecture notes, just a few preliminaries. What is important here that in 1942, Bohm joined the Communist Party. This was a fashion among young intellectuals in those days in the United States. It's not clear how much he was active there. In 1949, he was asked to testify before this committee, the McCarthy Committee. He took the Fifth Amendment. He refused to disclose names of his colleagues. And in 1951, he was suspended from Princeton University. In the meantime, he published his two masterpieces. One is a book, Quantum Theory, which he published after he taught a course on quantum theory in Princeton. And this book by Einstein, by the Israeli historian Mara Beller, is referred to as the best Bohrian book. He wanted to understand Bohr's attitude, what is later called the Copenhagen interpretation, and he wrote that book. In that book, there are already points of criticism which essentially anticipate Bohm's break with the Copenhagen interpretation. That could be, of course, a topic for a talk in itself. In 1952, he publishes these famous two papers where he proposes a causal formulation, a causal interpretation of quantum mechanics, which is then known as the Broglie-Bohm pilot wave theory, the Bohm mechanism. And I'm not going to talk about that. I'll mention it briefly. I'm going to talk about something very different. Now, before I continue, there was a Bohm was then in Princeton. There was a very close relationship between Einstein and Bohm. Einstein, they corresponded. When Bohm had to leave the United States, before he left, they just met because both were in Princeton, but then they corresponded on basic questions of quantum mechanics until Einstein's death. And Einstein, as you know, emerged as one of the most fervent critics of the Copenhagen interpretation. He opposed to the idea of a final theory that abandoned causal behavior, but actually what worried him most, what he opposed most, was not the indeterminism, was more giving up an objective reality of the physical world. Now, Bohm attributed his shift to the causal interpretation. He attributed it to the discussions with Einstein. And after receiving the hidden variables papers, Einstein wrote to Max Born, "Have you noticed that Bohm believes, as de Broglie did, by the way, 25 years ago, that he is able to interpret quantum theory in deterministic terms? That way seems too cheap to me." And Bohm was very surprised because that, according to his judgment, was compatible with Einstein's own view. Now, when Bohm had to leave the United States, Einstein wrote several recommendations to Brazilian authorities. Bohm is one of the most promising and original young theoretical physicists. And he also highlighted Bohm's moral stance in refusing to reveal the name of his colleagues. Now, Bohm in Brazil. Now, if you want to have a very comprehensive account of Bohm in Brazil, you can look at Olival Freire's 2 books, which I recommended here. There is much more than just Bohm in Brazil, and I'm glad that Olival is with us in the audience. And in Brazil, he continued his work on causal interpretation, extension of hidden variables model to include spin. But then what should be emphasized is his work with Pierre Vigier. You see, the authorities in Brazil gave him funds to do also, to continue his previous interests, and allowed him to invite visitors. Vigier was one of such visitors. With Vigier, they published a hydrodynamic model of the causal interpretation, and for the first time they introduced the subquantum level, about which I shall say a few more words. And Vigier, the work in Brazil was the beginning of a lasting collaboration between Bohm, Vigier. Vigier in Paris worked with de Broglie and other associates, and Vigier became the most active advocate of the causal interpretation even after Bohm abandoned it. But what is more important for our story, for the story that I'm going to tell you, is something else that happened in Brazil. In Brazil, it was a period of Bohm's deepening interest in philosophical aspects of scientific theories. And 2 individuals had something to do with it and a great impact and influence on Bohm's work and future activity. The first was Mario Runge, an Argentinian physicist who came and visited Bohm in Sao Paulo. Runge published articles in the Marxist journal Science and Society, and in particular, and I shall come back to that, he published an article on Lenin's concept, the infinity of the electron. And the second one was Mario Schoenberg, a physicist, another communist. You see, decent people in those days were communists. And another communist, he gave Bohm 2 pieces of advice. One was read Hegel, because every communist should read Hegel. The other, and that was what Lenin's dictum to all communists. Many heard that. Bohm took it very seriously. He started to read Lenin when he was still in Princeton, but he continued that with greater affection and interest after that. And the second advice, which is even more important, that Schoenberg gave him when he heard about Bohm's causal interpretation, he told him causality cannot exist alone. Causality epistemologically is equivalent and should go together with chance. Both have the same epistemological status. And then, following in Brazil, Bohm abandons the causal interpretation. Causal and statistical laws share the same epistemological status. And from that moment, dialectical materialism plays In the meantime, we can decide the conditions. One more. Let me. Is better now? Okay, I'm sorry. Okay. Now this is a list, a very impressive list of Bohm's reading. Now you have here a dialectical thinking. In modern era, the founder of that, the protagonist of that is Hegel. And we will see that Hegel, more than anybody else, had the greatest and lasting impact on Bohm's philosophy, even on his life. What is surprising, that in nothing that Bohm wrote, although it is Hegelian through and through, the name Hegel is mentioned, except in the lecture notes that we discovered. And that's one unique aspect of that, and we can speculate why. Then, of course, Lenin, Engels, he even read Mao Zedong on call. It's not clear how much he read Heraclitus and Parmenides. They are discussed, analyzed in the lecture notes, but it's not clear if he read them originally or he got their ideas from Hegel. Because Hegel said that everything that he did is already in Heraclitus. So this is this. Now, what did Bohm learn from this reading? His connection to Hegel was intellectual and deeply emotional. For Bohm, Hegel's philosophy became a framework through which he articulated his worldview. Hegel's philosophy aimed at a holistic understanding of thought and being, based on the principle that they constitute a single active unity. And Bohm's intellectual perspective was also shaped by the dialectical materialism, and I will explain to you what is the difference between dialectical materialism and dialectical idealism, Re Hegel. And it all has to do with how he understood quantum mechanics. This is not just something in the air. It's all connected to our theme, to the theme of our conference. And this is the understanding that Marx and Engels, although they said that everybody should read Hegel, they took Hegel and his dialectics and turned it on its feet and showed that it makes sense only if the object, the matter, is taken to be primary, while the subject is a special side of the former. And this relation between subject and object will be a key topic in my talk, because it is a key topic in Bohm's thinking and certainly in the lecture notes that we are now publishing. And subject and object in the context of quantum mechanics, of course, is the measuring apparatus, the subject, and the measured physical entity, the object. In a broader sense, the subject is our thinking, and the object is the external world. So all that is... now Lenin articulated this shift from Hegel to putting it upside down by, read this because it's a very interesting quotation. The contents of it is Bohm's leitmotif for his life. Dialectical materialism insists on the temporary, the relative, the approximate character of all milestones in the knowledge of nature. The electron is as inexhaustible as the atom. Nature is infinite, but it infinitely exists. It is this sole unconditional recognition of nature's existence outside the mind and perception of man that distinguishes dialectical materialism from everything else. And the basic implications of that, which Bohm adopted, and that is that the claim that there cannot be a final theory. This has to do with the infinity of nature. All physical laws have limited validity in their domain of applicability, and truth is always connected with error. Particularly the growth of knowledge is always connected with error. Now, the culmination of this should appear in my animation later. The culmination of this process of philosophical reflections on the meaning and interpretation of quantum mechanics was this remarkable book, a gem in the history of science, Causality and Chance. And although it is all Hegelian, it's all shaped by dialectical thinking, but the name Hegel and the name dialectic, the word dialectic, are not mentioned there at all. And the book revolves around these two principles which Einstein which Bohm extracted from his thinking, the unity of opposites and the infinity of nature. And Bohm's book offers a critical analysis of the evolution of physics, tracing its path from classical physics through field theory, statistical physics. It explores the nature of physical theories and the laws of nature. And now and Bohm's conclusion from this historical analysis is that physics is always uncovered and has always uncovered and will continue to uncover deeper layers of physical world, and that this progression will never cease. So this is the infinity of nature, and the laws of chance are just as essential as causal laws. Together they shape everything that exists, and this is the unity of opposites. And Bohm's criticism of the Copenhagen interpretation of quantum mechanics. What is the essence of Bohm's criticism at this stage? Yeah, he criticized Heisenberg's principle because it's regarded as final, as inevitable, a universal limitation of the maximum degree of determinism. Bohm argues that all attempts to prove the final and absolute validity of the Heisenberg uncertainty principle are inherently circular, following from the current general form of quantum theory. Now, he claims that physicists in those days, for better and worse, were influenced by philosophy. Just as Bohm was influenced by one kind of philosophy, dialectical materialism, and we'll talk more about it, the protagonists of what is called the Copenhagen interpretation were under the influence of positivism, and positivism, which dominated the thinking of physicists at that time, this doctrine asserts that one should not speculate about entities that cannot be observed through existing empirical method. Therefore, once you accept that, there is no room for a sub-quantum theory or sub-quantum principle that Bohm advocates. And the other influence is the influence of neo-Kantianism. And neo-Kantianism tells that we observe, what we observe are phenomena into which enter concepts and sense impressions. But the relationship between our concepts of phenomena and an objective world outside there is not only unknown to us, is unknowable to us. This is the essence of the Kantian stance. Now, Bohm's criticism is echoed in two classical books on the foundations and meaning of quantum mechanics. One is the late colleague of mine, a historian at the Hebrew University, Mara Beller, who wrote a remarkable book, The Quantum Dialogues, and there is a whole chapter criticizing the Copenhagen dogma of rhetoric, of finality and inevitability. And the other physicist who was deeply influenced by Bohm's attitude was John Stuart Bell. And in the collection of articles, the speakable and unspeakable in quantum mechanics, on many, half a dozen is many, but half a dozen occasions, he makes this distinction. The complementarity principle talks about waves or particles, the dualism between opposites, whereas Bohm talks about the unity of opposites. And he makes the distinction between that, but his major objective to Bohr's interpretation, to the Copenhagenist interpretation, is this vague separation or division of the world between the apparatus, the classical apparatus, and the quantum object that is measured. And this question of this division versus the unity of subject and object, which is a key theme in Bohm's lecture notes. A key theme, the unity between subject and object. We shall come back to that. This is also John Bell's accepted principle, and I don't have the time to show how that leads him even to the Bell theorems that we celebrate today. And what happened? Did I miss? That's okay? Okay. Now, there is in 1957, just 1 month before the lecture notes in Israel, a very special, unique conference took place in Bristol. This was the 9th symposium of the Colston Research Society. It brought together physicists and philosophers. I will tell you what I mean by the turning point. And they discussed foundational questions of quantum mechanics. At one session, David Bohm talked about his explanation of quantum mechanics. And then there was Leon Rosenfeld, who was one of the most harsh opponents to David Bohm, who coined the term the Bohm heresy, And the expectation was that by the Copenhagen adherents, that this conference will finally expose this heresy and get rid of anything that is connected with Bohm, but the opposite happened. In 1957, the Colston Symposium did play an important role in loosening the old guard's grip over the foundational questions in quantum mechanics, which finally led to a more open-minded and ideologically relaxed critical rehabilitation. And, here is David Bohm at that conference, and let's continue. Following that conference, there was maybe the first very favorable review of Bohm's book on causality and chance in modern physics. When Bohm published this book, he was a little disappointed that it was not received as well as he expected it to be received specifically by philosophers who ignored it. But after that conference, Feuerabend, a historian, philosopher of science, talked about this book very favorably, contains an explicit refutation of the idea that complementarity and complementarity alone solve all the ontological and conceptual problems of microphysics. And he then said, in short, this book contains a refutation of the idea that the physicist of the future is bound to be very similar to the more dogmatic of the medieval scholars, with the sole exception that now Bohr will replace Aristotle. Now, in 1955, in March, Bohm moves to Israel. He moves to Israel at the invitation of Nathan Rosen, who at that time chaired the Department of Physics at the Technion, and this is the Rosen of the trio Einstein, Podolsky, Rosen. And he stayed there, and at the beginning, this was a very tumultuous time in the world. It affected Bohm as it affected all intellectuals in Europe, and not only in Europe, and also in Israel. That was the time when Khrushchev exposed the Stalinist crimes at the 20th convention of the Communist Party. This was the Russian invasion of Hungary. Olival, in his books, talks about this time as Einstein's break with Marxism. But here, Olival, one should be a little more careful. It is true that it is his complete break with political Marxism. It is still not his break with philosophical Marxism. And actually, the group of the Marxist philosophers in Israel was formed to explore the possibility, is it possible to continue to adopt philosophical, ideological Marxism, but abandon political Marxism. So this is what happened then. And Bohm in Israel met a young scholar, Meshulam Grol, who was a member or Marxist of the kibbutz. He was more than just a Marxist. He was even a Stalinist in those days. But Grol was a great scholar of Hegel, whom Bohm really admired. They talked a lot. And they talked about the relation between the universal, the particular, and the individual in Hegel's logic. Now, this trio is a very central concept that has to do with nature of the laws of physics, and I will show you, I will mention to you how all that appears in the lecture notes, which we are now publishing. They talked about Hegel's approach to thought as a dynamic, evolving process connected to the external world through practice. Bohm began to think about thought during his time in Brazil, but only when he got to Israel did he realize how very important it is. They also talked about two other basic Hegelian concepts, essence and actuality. I don't have the time even to explain you what it is all about, but it is there. Now, all the topics discussed with Grohl are not even mentioned in that classic book, Chance and Causality in Modern Physics, because that was written mainly when he was still in Brazil. But all these topics are extensively, explicitly discussed in the lecture notes that I have just mentioned. That is their uniqueness, their novelty, and they will be exposed. I believe it will be a revelation and a surprise to the Bohm scholars worldwide. Now, this is the Hebrew cover, the first page in Hebrew of the lecture notes. The title is Philosophical Problems of Quantum Mechanics in the Light of Dialectical Mechanism, Materialism, and what is the essence of these lectures? These lectures demonstrate how dialectical materialism became the framework of Bohm's formulation of a comprehensive interpretation of science and human understanding of nature. There are, comparing these lectures to his book, I already told you what is the difference, the new topics, Hegel, Marxism, Marx and Engels, dialectical materialism, all that is discussed extensively and explicitly, and the lecture is divided into parts. The third part deals with problems associated with quantum physics, and the second part, which is the main Hegelian heavy context, very relevant to discussing Bohm's idea about science, about physics, and quantum physics in particular. It deals with philosophical problems related to scientific theories in general. Its goal is a deeper understanding of the unity of opposites and the infinity of nature, starting with the analysis of the universal, the particular, and the individual. Bohm demonstrates that in terms of these basic concepts, the dialectical character of all things become clear. In addition to that, there is a detailed treatment of specific topics which emerge from discussions with Meshulam Grohl. Let me continue. There are hints, by the way, that Bohm planned to write a book on dialectical materialism. His biographer, David Peat, tells us that for a time, Bohm even planned to write a book on dialectical materialism, but he became discouraged when he thought of the positivistic and idealistic baggage that even his friends on the left carried. In a letter to a friend, Miriam Yevi, there are hundreds of letters exchanged between them. Bohm writes, as for the book on dialectics, this also could not be done under present conditions because of lack of adequate interest and stimulation. Apparently, in Israel, he found an audience with that adequate interest and stimulation, and it is clear from the lecture notes that he had this text ready before. It is well organized. It is language edited. It is not something that one of the attendants, a student, would take notes and then print. So this is what we have here, and it starts with 5 basic questions. There are the problems of quantum theory, continuous versus discrete, causality versus chance, subject versus object, identity versus different, and quantum logic. Yeah. So this is what he does here. Now I am going, because the chairman showed to me that there is a 5 minutes, so I will skip. You can have my presentation, and I will go to some lessons that we can learn from that. So I do it fast. I'm not telling you what it is. This is the table of contents of all the topics where he discusses quantum physics. This is the Brownian motion analogy. Huh? Epistemology, what knowledge is, what it means, and how it is related to the reality of all. And finally, there is a long discussion about Bohm's philosophy, which concludes that the growth of knowledge is a process which always begins with the unity of truth and error. Now, I am skipping this, and now I go to the history of quantum mechanics. This is important. I will finish, don't worry. Don't worry. Don't worry. You see, if you didn't take the time of introducing me, then I would have more time. You overdid it. Anyway, so you see, quantum mechanics was founded 100 years ago. It ended with the Copenhagen interpretation, and the Copenhagen orthodoxy discouraged any discussion on foundational issues. Einstein referred to the Heisenberg-Bohr philosophy as tranquilizing. It is so ingeniously contrived that it provides for the time being the believer with a soft pillow from which he can no longer be so easily roused. And David Mermin, said that for him, the Copenhagen interpretation means one thing: shut up and calculate. All this changed in the 50s with a trend, with a discussion back to discuss the foundational issues. There are 3 books here which described it very well, and I again quote Olival's book, and the subtitle is interesting on Olival's book here, Rebuilding the Foundations of Quantum Mechanics. And the question is that we'll raise with you now. We try to answer it in our book. There are 2 questions. What was Bohm's role in the renaissance of the quantum debates? And the second question, just paraphrasing on that, can we say that dialectical materialism saved quantum mechanics? And our answer is the legacy of Bohm in the history of quantum mechanics. And let me emphasize this. Bohm's version of quantum theory never became a dominant view, not even among physicists with Marxist conviction. Its merit is its effect on the present phase in its history through its contribution to challenging the Copenhagen interpretation. We claim that Bohm was one of the earliest and most significant voices stirring up a renewed interest in the foundations of quantum physics. We also claim that the reasons why this wake-up call was actually heard had to do with the role that dialectical materialism played in the debates on this interpretation. And let me go further. there is Bohm's critique of von Neumann's proof that hidden variables did not exist. It had a great impact on John Bell. It had a great impact on Bohm's contribution to the understanding of the concept of non-locality as a basic concept, a basic attribute and the discovery of the unpublished lecture notes on quantum physics and dialectical materialism sheds a striking new light on this role of, we think that in the general perception of the history of quantum physics, Bohm's contribution has not yet been fully appreciated. This is one of the main messages based on this. Following, I have 2 slides only. Fine? All right. Following that period, there was an esoteric term in Bohm's intellectual beliefs, and he abandoned all talks about dialectical materialism. He was fascinated by the writings and teaching of this Indian philosopher Jiddu Krishnamurti, with whom he spent 20 more years. His great book on wholeness and implicate order is all from that time. He did not abandon his own previous existence as a physicist and also as a philosopher. And much of his later thinking still had its roots in what he expounded in the lecture notes. In particular, he saw his earlier quest for holistic understanding of the world in line with Krishnamurti's teaching. But he went beyond the search of his fellow physicists like Einstein for a unified world picture, because for Bohm, a true unification should now also comprise the role of consciousness. And let me go, this is my last slide, my conclusion. Because we have here a unique example of a great physicist. I don't have time to tell you what his contribution to ordinary physics was before these notes and after these notes. Yet he was not able to separate everything that he did in physics from philosophical reflections. He could not see an inherent separation between science and philosophy. And he was not afraid to rest both with Western and Eastern philosophical tradition to make sense of modern physics. And Bohm lamented toward the end of his life, when he was interviewed, the American Institute of Physics produced interviews with Bohm, and then he lamented that contemporary research and teaching in physics had become overly focused on mathematical formalism, neglecting the underlying ideas. The standard opinion of physicists is that philosophy is just a bunch of arbitrary assumptions, and that the real thing is the formula. Everybody understands the formula and agrees with it and says that is what gives the result. And in that sense, he reminds us of Albert Einstein, another philosopher scientist whose scientific endeavors were always intertwined with philosophical and epistemological reflections. Both men shared a deep disappointment and expressed it explicitly in their later years. They were disappointed that the physics community had abandoned the pursuit of a unified philosophical, scientific worldview. And now I thank you.
Thank you very much for your talk, which reminded to all of us the role of David Bohm. We turned off the air conditioning, so until then there are issues with the temperature, of course. We'll try to open it, turn on it again. So we will have 10 minutes, and because of this, I mean, the lunchtime. There is 2 questions right here, so please raise your question if you have. So 3 questions, we can go up to 4 questions, and then it's too late.
Professor Hanoch, first, congratulations for the wonderful talk. I think that we are happy and we have the honor to see this primer before the release of the book. So first of all, thank you very much. Secondly, in your talk, you suggested a question why Bohm did not cite Hegel and even Lenin, etc., in his writings. I think that he did not cite explicitly, yeah.
Because he used it all the time.
Yeah, he used the jargon, but not the reference. I think that this, it's my question to you, this demands a double answer. I would say that in his times, in the US and in Brazil, I would say that he was afraid, not of ideas, but he was afraid of the hands of McCarthyism. You needed to consider that his passport was confiscated by American authorities when he arrived in Brazil. It was also the time that the couple, Rosenberg couple, were sent to the electric chair in the United States. So it is, I think that it is comprehensible, it's my guess, that he did not cite even Hegel in his writing at that time.
Thank you.
You are right that he found in Israel, I would say, a more safe place, even if Israel was in war at that time. But you should remember that in Brazil there was a strong political crisis at the time. Brazilian President Getúlio Vargas committed suicide in the wake of this crisis in 1954. Then I think that from then on, why he did not cite later? This is a good question to be investigated. My guess is that the transition from the commitment to Marxism to a different worldview, not from the philosophical point of view, you are right, I totally agree with you. In 1956, what happened, it was a political breakdown, but the philosophical views evolved. Then we need to see how consistent he was in this evolution. From my impression is that the most important contribution of the manuscript you discovered is that now we can see that in the end of the day, ultimately, Hegel was more influent on even Bohm's later reflection than it was influenced from Krishnamurti. So thank you very much for
Thank you for this remark. Actually, we speculate exactly along these lines why in the book Chance and Causality in Modern Physics, Hegel and dialectic thinking is not mentioned. But why it is not mentioned in the implicate order in that book, that's another question to which you now offer an explanation, which has to be explored. We did not relate to that.
Thank you, Hanoch. This is very exciting find, a very exciting publication. One thing that I'm very curious about, sort of, you know, in the course of this argument of these lectures, does he then come back to sort of justify a specific interpretation of quantum mechanics in terms of dialectical materialism? I mean, you sort of implied, it's definitely, obvious that, it's a good ground to criticize Copenhagen, but does he claim that sort of, dialectical materialism then really forces you to interpret quantum mechanics in a specific way, in the way of his fluctuation theory?
Very explicitly, even more than before, in the context of the infinity of nature and the unity of opposites, and especially in the context of his discussion of the Hegelian logic based on the universal, the particular, this tells you what laws of physics should be like, how they are formulated in one domain, what is universal is particular in another domain. All that has to do with his view of quantum mechanics. He shared a little bit of it with Einstein. Einstein disliked it, did not like it at all. For Einstein, the dictum or the belief was simplicity. This was too complicated for him. He said it explicitly.
Hello, thank you very much for your talk. I would like to know if I understood better. I understood right. Are you claiming that Bohm never abandoned the dialectical materialism as ideology, a philosophical ideology? And if he didn't, can you explain a little bit better what's the difference between the this Hegel emphasis in dialectical materialism, and also what's the difference between this emphasis in unity and the relationship with individual in Hegel? And after, because in these dialogues between Bohm and Krishnamurti, they emphasize very much also this unity and this relationship with individual things.
Yeah.
Thank you very much.
No, I didn't claim that. I didn't claim Bohm did abandon materialism, dialectical materialism. He did not abandon dialectical thinking of Hegel. The difference between the two, I can tell you in one sentence. There is this question of subject and object, the relation between thought and being, the entity of everything, and how it is related to thought. In materialism, there is what is called the objectivity of the subjective and objective. In non-materialism, the other way, it is called the subjectivity of the subjective and objective. That means in materialism, the external world dominates, the object dominates. Thought is part of the object, of the external world. It is united and part of the external world. Both together act as an object. In idealism, it is the other way around. I could go more into that. This is in a nutshell. No, there are, takes it from, I mentioned Heraclitus and Parmenides, and there was a big debate then if non-being is also a being, is an entity. And that was Heraclitus, and that it was what is accepted by Bohm, the being of non-being and being. That non-being and being are a pair, a united pair, which are an entity. And the same goes with the distinction objectivity of subjective and objective and subjectivity of subject. But it's a little too complicated, but this is what it is. This is about Bohm, this is how Bohm explained it, this is how we comment on it.
Okay, there is time for one last question.
There is one more question.
Yeah, the last one, and then we need to stop the session. Please.
I can talk to you more about it.
But please talk on the microphone, otherwise the people at home will not hear you.
But I talk with my hands sometimes.
I want to thank you for a fascinating and very engaging talk. My question has to do with the awareness. My question is, in the broader scientific and physics community, to what extent were physicists aware of Bohm's tendency to tie his theoretical work to his political ideology? In other words, did physicists in the North and the West react to Bohm because of his political ideas, or was that more hidden and not really a factor in the way that the Copenhagen interpretation and others responded to him?
Well, you have to go back to Oliver's remark. If they did or did not, Bohm was very concerned that they would, and therefore he was cautious in the use of words. It depends. You see, John Bell was a great believer, promoter, advocate of Bohm's theory. But he did not connect it with his philosophical ideas, although he used this unity of subject and object, this unity of wave and particle, this really the dialectical unity as an argument. For Bell, Bell has an article on 6 interpretations of quantum mechanics. Out of the 6 interpretations, he claims that the Bohm's interpretation stands more grounds than all the others.
Thank you very much. Please let me thank again Hanoch Gutfreund.